Hey, g'day, it's Prezzo here, back in the shop. Thanks for joining me. This is the fifth and last episode in a series I've been doing called Metal Finishing with Mark. And the title of today's episode is Zinc Plating 101. Now, you may have seen me messing around with this little project in previous videos. This is a miter fence that I've been doing up for a metal cutting bandsaw that I converted from a wood cutting saw. I've got a playlist if you want to go back and look at that, and there is a playlist for all 5 videos on metal finishing. I'll put a link in the description. Go and have a look at those if you like. But on this miter fence previously, I powder coated this aluminium casting, and this little knob was manufactured here in the home shop, and I anodized that here at home. But this steel section here is just mild steel. When I got it, it was badly corroded. I've stripped the corrosion off that, cleaned it, I've sort of rubbed it back with emery paper, but every time I do it the corrosion comes back. And you could oil it, but if it's one of those tools you put aside, you don't use very often, you sort of forget about it and the oil evaporates off and you come back and you find it looking terrible. Now this is a little, I don't know, it's like a longitudinal study that I've been running on corrosion, and I get this problem in my home shop where anything made of mild steel will end up looking like that. So that's just cold rolled mild steel. I cleaned that and polished it about 12 months ago, and I just left it out on the bench. And you can see that it's got severe surface corrosion and pitting and so on, and that'll just get worse. But these 5 samples here were all done using a process called parkerising. Now, I've done a video on this, you can go back and look at it if you want, but parkerising is a hot chemical process that creates a crystalline structure on the surface of the steel, and it's slightly absorbent, so we'll pick up oil or wax or some other sort of protective film that goes on there. And these have been sitting around the shop for the same length of time as that original part that I showed you, and these are still looking as good as when I did them. That's the sort of protection, the level of protection I want to get on this part here, but I don't really want it to look black. So I'm going to do this as a zinc plated part. Now, here's a couple of examples of commercially made parts that have been zinc plated. So these are those, washers, the big flanges that you find on a 200mm grinder for holding the wheels on. This one has been zinc plated and probably clear passivated or done with what they call a blue passivate. This one, same, but it's been done with a gold passivate. Here are 2 items that I did in the home shop using the same process. So these are just some big washers that I had lying around. So same thing, zinc plated and then done with the blue passivate, this one done with the gold passivate. Now this gold finish, you may have seen that around fasteners on car engines and so on, and in years gone by they would have done that using a process called cadmium plating. But cadmium is very toxic and it's a heavy metal and it's not used very much for environmental reasons. But the zinc plated and passivated finish is very similar. Now it's not as good as hot dip galvanizing, but for indoor use it's fine, and I did these 2 parts probably 18 months ago, and they've been sitting around a drawer and they still look as good as when I did them originally. So for the home shop, zinc plating is a good protective finish. Now it's not as good as nickel or chrome, but it's a lot easier to apply, and there's probably fewer steps in the process. Now it does require you to invest some money in chemicals and cleaners and a few other items that we'll look at today. But yeah, I think it's a good option for a home shop situation. So let's have a look at what we're actually going to do. So these are the 3 items. Like I said, this steel tongue here, we're going to do that in a zinc with a clear passivate. This one is just a big washer. I think it's, I'm not sure what it was for, but it's been painted. I'll sandblast that back to bare metal and polish it, and we'll do that one with the zinc plate and gold passivate. This is a bracket off my milling machine. It comes off the X-axis stop, and it's a bit stained, corroded and nasty. I think I'll do that one as well. And what I'll do off camera is do all the preparations. That means sort of cleaning, stripping, deburring, polishing. Then we'll come back and look at those before they go into the zinc plate bath. Now there are the three parts. Having cleaned those up, I did these two in the sandblaster. This one here has been buffed on one side with a Scotch-Brite wheel, and the other side is as it came out of the sandblaster. So we use this one as a bit of a test piece or a control, just to see what difference we get with the zinc plated finish. This one I also sandblasted because it had some really difficult corners in it which were corroded, and I went over that also with the Scotch-Brite wheel. I'm not too worried about the finish on this one because someone has damaged this quite badly with socket head cap screws being tightened down so hard it's bruised the material around that slot. So that's fine for that one. Now this one here, I went to a bit more trouble. I draw filed it, I cleaned it with emery cloth, and I went down to some very fine 120 grit emery cloth. And the thing is that it's been sitting around for a long time in a corroded state. You can see that pitting in the surface there, and that pitting is very deep. You'd really have to machine that off if you wanted to get that back to a clean finish. And I just couldn't be bothered really. I just want this to not corrode. That's my main thing. And the thing about zinc plating is that it is a functional finish. If you want a decorative finish, you need to go to something like chrome or nickel plate, and both of those require that you get the substrate, the underlying metal, to a mirror finish. And that is way too hard for me anyway on steel. I don't have the patience for it. Copper and brass, a little bit easier, but on steel, forget it. I'll just get it looking okay, and then we'll go with that. So the next step is to get these chemically clean, and then we're going to go into the zinc plating bath. I want to run you through the basic equipment that you'll need for doing zinc plating in the home shop. First item that you'll really need is a variable power supply, DC. This one does up to 32 volts and up to 5 amps. It'll work in constant current or constant voltage mode. And this is the same unit I use for doing anodizing in the home shop. If you have one of these, you can carry out most of the plating operations plus anodizing, and these little units are not terribly expensive. I found this one to be nice and compact, and it makes a good bench power supply as well. The next essential item that you're going to need is a pair of zinc anodes. Now, I started off by using zinc flashing, which was left over from a job that I'm doing on the roof of the house. And I had a bit of a problem. I suspected that the anodes might have been contaminated, so I purchased these from a company which we'll talk about in a minute. But these are cast zinc, and they're supposed to be 99.99% pure zinc. You sort of need a minimum of 2, so you can place one on either side of the part that you're going to be plating, and they can be hung in the tank by a pair of stainless steel wires or copper wires. They do suggest that you don't store these in the zinc plating solution. They should come out and be cleaned and dried, stored away until you use them again. So that's the next thing. You must have zinc anodes. Next thing you'll need is some sort of a zinc plating tank and a zinc plating electrolyte. Now there are a number of home brew solutions that you can use. In fact, I started using those, and a lot of them are just made up out of household items that you probably have lying around already. But I actually bought this as a ready mixed crystal solution which you mix up with demineralized water. And so far it's been performing really well. You'll need something to hang your parts on. In this case I've just got a bit of copper water pipe. I've cut a couple of slits in the side of one of these 5-litre plastic pails. These have good snap-on lids, and they will reduce the evaporation of your zinc plating solution when you're storing it. And that's nice and secure, it's not going to go anywhere. And you can just hang your 2 zinc anodes down either side, and then the parts that you're plating will hang from that copper bus bar. Now, the zinc solution that I've got here makes up 4 litres, but there is a version that will do 20 litres, depending on the size of parts that you're doing. You do need to look after this stuff. It's really important you don't contaminate it with dirt and rubbish. There is a bit of scum on the bottom of that at the moment, which I'm not sure where that's come from, but it doesn't seem to affect the overall performance of the zinc plating. Next thing you'll need is some sort of a cleaner for your parts. Now, like all of these operations in the home shop, whether it's anodizing, zinc plating, nickel plating, you must have your parts extremely clean. So they must be free of grease, wax, oil, fingerprints, and the best way to do that is to buy or use some sort of a fairly strong alkaline cleaner. Now you can use household cleaners for this, Ajax, Jif, any of those sort of slightly abrasive cleaners will do well. Once again, I bought this stuff and I just hang the parts in that solution for half an hour or so, but then you still need to scrub the parts. So you're going to need some sort of a brush so you can get to work on that and get into all the nooks and crannies, make sure that you've got out all of the traces of any cutting oil or grease that might have been on the part. All of that's got to come out before you think about putting in your plating tank. Okay, if you've got everything I just showed you, you're pretty much set to go with zinc plating in the home shop. However, some time ago I bought myself this book. Now it comes from a company called Jane Kits. Now they're an Australian company. They have an online store. All their products are reasonably priced and readily available. Now, full disclosure, they're not my sponsor. They don't give me anything. I pay for everything that you see here. But I recommend them just simply because the book is written in plain English. It's simple to understand. It's comprehensive. Now, the book itself covers more than just zinc plating. There's the list there of what this book covers. And it's easy to understand, like I said. So I've read up on my zinc plating process, so let's give it a shot, see what happens. Okay, the key to success with any of these plating operations, or anodizing for that matter, is to make sure that your parts are absolutely clean. I'm using a product here called Parts Wash, which came from Jane Kits. You buy that as concentrate, you mix it up with 4 litres of water, just demineralised water, and then you've got to scrub that part. Now I've actually had this soaking overnight. This is a piece of copper. I polished the copper and I'm just using this as a test piece just so you can see how quickly the zinc deposits on that surface there. So being copper, we'll see the colour change very quickly. So you just scrub it and keep checking it, and the way you check it of course is you rinse it off with water. Now if the water hangs on the part like that in a sheet, then you know it's ready for the plating solution. If it beads up, then there's something on there, there's contaminant on it, and you need to go back and do that process again, the cleaning process. Okay, let's go and put this in the plating bath and we'll have a look, see what happens. It should go without saying to make sure you protect your hands and protect your eyes when you're working with any of these materials. So wear gloves, wear a pair of safety glasses as well. And I'm giving this one final rinse in clean water before it goes in. And what I'm going to do is I'm going to half submerge that in the plating solution, and we'll let that plate for about 30 to 40 minutes, which is the recommended time. And then I'm going to dunk it again up to the Y here for another, say, 30 seconds, and then we're going to take it out and clean it and just see what happens. Now I've already got my power turned on, and as soon as it makes contact with this copper bar here, it will start to plate. So I'm hoping you can see the colour change. Let's just see. I've got to get my depth just right here. So I'm hoping you can see that that's already plated. So almost the instant the current starts to flow through the part and the plating solution and your anodes, you should be able to see zinc deposited on that copper almost straight away. Now you can let that plate for a minute and take it out and it will look zinc plated, and it'll be reasonably well protected, but the coating is going to be very thin, and that's what I'm hoping to show you when we finish up with this little test here. Okay, for what it's worth, that's currently drawing just under 0.8 of a volt and just over 0.2 of an amp. Now I've set my voltage to 5 volts, but it's not getting anywhere near that, and the amperage I limited to just over 0.2 of an amp. Now there are calculators which will tell you the specific amount of amperage that you need for a particular part, but in reality it's never worked for me. I'll just set it to 5 volts, let it draw whatever amperage it wants, and it seems to work okay. If you go for too high an amperage, you can get an effect they call burning, where the zinc plating will go terribly black and crusty and look horrible. So just keep your amps down low, and as you can see there, even on 0.2 of an amp with that part, it's plating quite well. So let's just let that work away and we'll come back in about half an hour. Okay, that's been in there for about half an hour now. That's probably the lower limit on what you might want to do, depending on how much corrosion resistance you want to have on that part. The recommended time is between 30 minutes and 45 minutes. But what we're going to do now is I'm going to dunk that part completely under the solution, and we'll plate the remaining top section of that copper strip there, and we'll do it for 30 seconds, and then we're going to take it out and I'll clean it, show you what difference it makes. So I'm just going to bend that hook a bit higher up. Okay, let's hold that for 30 seconds. Well, that's probably closer to a minute, but we'll take it out and have a look at it. Okay, if I take that out now, you can see that the top half is really shiny and the lower half's got that dull grey colour, but don't worry about that, that will come off. So we'll go and give this a clean and have a look at the comparison between half an hour and say a minute. What you might be able to see there now is the top part of that only had say a minute in the solution is quite shiny, and the bottom part there is sort of a dull grey colour. What we're going to do now is buff that surface off and see what difference we get. When I do this, I'm just using steel wool. And you can see that some of the shine is coming back to that now. Now what I was hoping to show you is that the difference in the thickness of plating. So to get the plating off the section that was in for half an hour, you've really got to work at it. You know, you really have to strongly abrade that surface to work your way through the layer of zinc and get to the copper underneath. But in the top section, which is really shiny, it's not going to take much work at all. So let's try that. So once again, just ordinary steel wool. And now you can see the copper is showing through at the top, but in the bottom section there where we left it in for half an hour, there's still quite a thick coating of zinc on that. Now obviously if you keep going, you're going to get rid of all of the zinc and get the copper back again. But it just demonstrates that the longer you leave it, the thicker the coating is going to get. Let's go ahead and do our steel parts now. Okay, I've got 3 parts to go in at this point. I've got a little tiny round head screw which goes on the miter gauge for the bandsaw. Now we've got our bracket in there, that's for the milling machine, and we've got this big washer here which is just really a part to demonstrate the next process. So we'll get all 3 of those in there. And the thing about steel is you can never really be sure whether it's plating or not, because the coating that goes on there is the same colour as the steel initially. But as it goes along, you see it start to get that dull grey colour, and you know that you've got some zinc being deposited on the part. So same deal, we'll leave that for half an hour and we'll come back and take them out and I'll show you the next process. One of the recommended procedures here is to keep the solution agitated. You can fit one of those little aerators into the mix and just bubble some air through it, or just give it a bit of a stir every now and then, which is what I'm doing. Now these have been in here for about half an hour, so we're going to take them out. I'm going to do that same process with the steel wool, just to bring the shine up on the parts, and then we're going to dip them in a passivating solution. So we'll do this big flat washer first. So that's what it looks like. That was the polished side and that was the sandblasted side. Now, I know it looks awful, but let's do the next step. Now we'll get our steel wool. And you can see that almost straight away the shine comes back when we hit it with the steel wool. But don't touch it with your bare fingers. Remember, this was the sandblasted side, and that's not going to go anywhere near as shiny. Now don't overdo this step. You are actually removing the zinc from the surface when you do this. There's a little bit of minor staining on that, but I'm not too bothered. Remember, this functional finish, it's not decorative. Now, some people seem to be able to get this to come out of the zinc plating solution absolutely shiny like chrome plate. And honestly, I don't get it. It's never worked for me. Either they found a new way to use Adobe After Effects that I don't know about, but I'm happy with that finish there. So let's go ahead now. We're going to put this in the gold chromate dip, or the gold passivate dip, and see what effect we get. Now, Jane Kits sells two of these. This one's called the gold dip, and there's another one just called blue dip. The gold one is the more spectacular of the two. So the way this works is we're going to dip this in for about 30 seconds and take it out and not touch it. So just agitate that around a bit. And that's it. Now, as that dries, it'll take on that sort of beautiful gold iridescent finish, but it takes some time for that finish to actually dry, and you mustn't touch it during that process. So let's go and hang this up, and we'll check it out tomorrow and see what it looks like. All right, there's our bracket, and once again, it doesn't look very nice, but let's get that buffed up with some steel wool. Just while I'm doing this, if you've got a vapor honing set up, this is the ideal candidate to do in vapor honing. It will bring up the shine almost immediately, get you into all the little nooks and crannies, which is hard to do with steel wool. Give that a good rinse. Now we'll put this into the blue dip, and you won't notice any difference. So this is the blue dip, sometimes just called a clear passivate, and same process, about 30 seconds, but you won't notice any difference in the colour. Maybe it will have a very, very slight blue sheen, but that's about it. This is more about producing a surface which is more resistant to the zinc being corroded off. So it's just like a clear protective finish, really. So almost no difference in the appearance, but we'll let that hang. Once again, don't touch it, just let it hang and dry, and then it will have that extra level of protection. To run that last part, it's not going to fit in my 5-litre bucket, so I swapped over to a rectangular container here. It's always a good idea to have a number of containers, different shapes and sizes, to fit parts that might be long and skinny, or big and flat. This one will be fine, so I'll get it rigged up and we'll do the last part. So ideally you don't want the part resting on the bottom of the container. I've got one point or one corner resting on that plastic there, but I think it'll be fine. The solution can get around that. And of course you don't want to touch the part against either of your anodes, otherwise you're going to get a dead short for your power supply. So just arrange your anodes so they're either side of the part and that you've got a good distance between them. I'll be doing that one in the blue chromate dip because I want it to look clear. I just want the zinc look to it. Okay, so that's had more than an hour. Actually, I forgot about it. We'll go and give this a rinse and scrub it up with the steel wool, and we'll do the blue dip on this one. So once again, just remember, don't touch the part at this stage with your bare hands. So we're just removing the sort of the smut on the outside. This exposes the fresh zinc underneath that, just that light layer on the outside. It's always going to be a bit difficult to clean up around that screw there. We'll just do the best we can. I know that doesn't look like a chrome plated part, but it's not meant to. So this is just for corrosion resistance. So we'll do this one now in the blue passivate. So unfortunately I'm not going to fit all this in, but But we're just going to give that about 30 seconds, both ends. And again, we're just going to hang this and not touch it for another 24 hours. So let this dry thoroughly. Well, here's our parts after 24 hours, and this one here, it's come out really, really nice. And that's the polished side, and you can see that almost iridescent gold with sort of blue highlights in it as well. Now the back of this is not so brilliant, so my recommendation wouldn't be to sandblast, or at least if you're going to sandblast, polish again afterwards. But that looks absolutely brilliant. I love that. These are the parts that are in the blue passivate, and these have come out really good too. It does have that sort of slightly iridescent sheen to it, so really happy with those. This is the part that was so rusty when I started. And you know, the look of that is, well, that's fine. I'm happy with that. So I think we put this guy together now. There you go. Typically, as soon as I get the camera out, it starts to rain. But I did powder coat that little pointer just off camera. And there's our finished part. So super happy with that one. That's going back on the bandsaw. This guy's going here. I'll tighten all that down later. Typical, isn't it? There's always one that doesn't want to go. So there you go, doesn't that look beautiful? And if you're wondering what this machine is, well, it's all going to be revealed in my next video, so you're going to have to wait till then. Some of you already know, but check out the next video. We're going to be looking at the big picture. Anyway, let's go back and recap what we've learned about metal plating in the home shop. So just to finish this off, my recommendation would be to make sure you get a decent power supply. This one here I found to be reliable and compact and lightweight, does a good job. The other thing probably is to make sure that you get decent quality zinc anodes. If you choose to use zinc flashing, just make sure that it is relatively pure zinc. These ones here, once again, they're going to outlast me, that's for sure. So probably a good investment on my part. Next thing, make sure you get a decent wash to clean your parts and make sure they're chemically clean before you try and do any sort of plating at all. This one that I got from Jane Kits, I found it to be reliable. Does work better if you soak it for an hour or so and then scrub it. It probably would work better if you heat it up as well. Although I've always used it cold and it's worked fine for me. Now with regard to these dips, I call them a passivate or a chromate. Apparently the names are interchangeable. And these are not really essential if you're doing any zinc plating around the home shop. I use them more for a decorative finish, but it does make your parts more durable after the zinc plating process. So the gold bright dip is the one that gives us that beautiful iridescent gold color on the parts. Is simple to apply. It's like adding a clear coating over the top of your zinc. So in my view, these are worth the purchase price. And if you're looking to put these parts anywhere in a corrosive environment, say outdoors, it'll just give you that extra layer of protection. But certainly these are not truly essential if you're doing zinc plating. Now remember I mentioned my little longitudinal study. Well, I've done an extra part. So this one I've done with the same zinc plating process. I've done the yellow chromate or the gold dip on this one here. And I'm going to put it alongside all of the other samples and just leave it and see what happens. So, you know, revisit this in years to come. I don't know how long it's going to take, but we'll come back to it and just see whether this coating holds up over time. But remember, this is indoors. It's not being subjected to sort of rain and dust and sunlight and that sort of thing. But, you know, none of these zinc-plated coatings are designed to be in that sort of environment. If you want that, you need to go to a hot dip galvanized product. So there you go, that's it. We're going to finish up here now, and I guess you want to see this thing and how it performs on the bandsaw. So let's have a look. Well, there you go. Not the fastest thing in the world, but it'll do me. Okay, thanks for watching. Check you on the next video.